Lift your view high above the solar system, up over the north pole of the sun, and look straight down. From here, the chaos resolves into a strange kind of order. The planets are not scattered at random. They circle the sun in the same direction, counterclockwise, riding in nearly the same flat plane, like horses on one vast cosmic carousel, and it runs deeper than their orbits. Nearly every planet is also running on its own axis the same way, spinning counterclockwise as it goes. The whole system looks like a single machine built by one hand, every part moving in agreement. This view, looking straight down the sun's axis, is the honest one, and we almost never use it. The familiar textbook picture lines the planets up sideways in a row, which quietly hides the most important fact about them, that they share a plane and a direction. There is even a precise reference for it, a kind of master level called the invariable plane, defined by the combined spin of the entire solar system, and the orbits of the planets hug it to within a few degrees. Seen from above, that shared swirl is impossible to miss. Then you look closer and the agreement falls apart. One planet, Venus, is turning the wrong way, backward, and so slowly it hardly seems to spin at all. Another, Uranus, refuses to stand upright like the rest. It lies flat on its side, rolling along its orbit like a barrel. These are not minor quirks. They are worlds that openly break the one rule everything else obeys. So, if all of us were born from the same spinning cloud of dust, why don't we all turn the same way? Why are most planets upright and quick while one is tipped over and one runs in reverse? What follows is the story of how a world gets its spin, and how a few violent moments long ago knocked some planets clean off their axis, leaving a record you can still read today just by watching them turn. To understand the rebels, you first have to understand the rule, and the rule begins before the planets existed. Our solar system started as an enormous cloud of gas and dust, light years across, drifting quietly in space. Some force disturbed it, perhaps the shock wave from a nearby exploding star, and the cloud began to collapse under its own gravity. As the cloud fell inward, a tiny initial spin became the most important thing about it. Every cloud like this carries some faint rotation to begin with, and as the cloud shrinks, that rotation speeds up. You've seen the same trick performed by a figure skater. When a skater pulls their arms in tight against their body, they suddenly whirl faster, even though nothing pushed them. The spin was always there. Drawing inward simply concentrated it. Physicists call this the conservation of angular momentum, and it is one of the most stubborn rules in nature. Spin does not vanish. It gets shared and amplified, but the total is always preserved. So the collapsing cloud turned faster and faster as it tightened, and just like water swirling toward an open drain, it flattened out. The quickening spin flung material into a wide rotating disk with the newborn sun blazing at the center. Every planet, every moon, every asteroid grew out of that one spinning disk, condensing from the same swirling material like clumps thickening in a turning bowl of batter. This is the source of the harmony, because everything formed out of a single spinning disk. Everything inherited the disk's motion. The planets orbit the same way because the disk turned that way, and most of them spin on their axes the same way for the same reason. A planet's rotation is a holdover, a fingerprint of the giant whirlpool it was born inside. By rights, every world should be a near copy of that original spin, standing upright and turning the same way, like parts stamped from one mold. Which is exactly what makes the exception so loud. A planet spinning backward or tipped onto its side is not merely odd. It is a violation of the deepest pattern in the solar system. Something had to reach in after that planet had formed and physically change it. To find out what, you have to travel back to a time when this whole region was a far more dangerous place. The calm, orderly solar system we know is the survivor of a staggeringly violent childhood. In its first few 100 million years, the spinning disk did not produce 8 tidy planets. It produced dozens of half-finished worlds, protoplanets careening along crowded, overlapping paths. Space back then was not empty. It was a shooting gallery. These young worlds did not politely keep their distance. They collided. Think of a pool table the size of the solar system, racked with planet-sized balls, all rolling at once, with no one keeping them apart. Again and again, worlds slammed together. Some shattered outright, some merged into something larger, and every major collision rewrote the spin of whatever was left behind. The key idea is to feel for yourself. Take a spinning top running smoothly on a table, then flick a marble hard onto its side. The top does not stop. It keeps spinning, but now it wobbles, leans, and points its axis in a new direction. A planet behaves the same way. A large enough impact landing off-center does not switch a world off. Instead, it tilts the world, speeds the spin up, slows the spin down, or, in the most extreme case, reverses the way the world turns. The spin survives. The orientation does not. Our own planet carries a scar like that. The leading explanation for the moon is that the young Earth was struck by another world about the size of Mars. A glancing, catastrophic blow that threw an immense cloud of debris into orbit, which then gathered into the moon. That same impact almost certainly helped set the tilt of Earth's axis, the modest 23-degree lean that hands us our seasons. We owe the rhythm of our entire year in part to one ancient collision. You can still read the evidence with your own eyes. The face of the moon, scarred all over with craters, is a frozen snapshot of that bombardment, an era when debris rained down constantly across the inner solar system. Earth took the same battering. Our craters were simply erased over time by weather, oceans, and drifting continents, while the airless moon kept its record intact. The calm sky we look up at is the cleaned-up version of a former war zone. Multiply that across the whole young system and the picture sharpens. Every world was a target. Some took hits that barely nudged them. Others took blows so severe that their spin was bent badly out of line with the disk they came from. The uniform rotation everything started with was, in many cases, scrambled, and what we see now billions of years later is the frozen aftermath. A planet's spin is a kind of memory, holding the sum of every great impact that ever survived, and two planets remember a far more brutal event. Before we meet them, it's worth saying plainly how strange this makes our neighborhood. The night sky looks fixed and serene, yet the spin of every world in it is a souvenir from an age of routine catastrophe. Hold that thought as we look at the two clearest survivors of the chaos, because each one breaks the rules in a completely different way, and for reasons scientists are still arguing over. The first turns backward, the second fell over. Start with Venus, the planet we like to call Earth's twin. It is nearly the same size, built from much of the same material, sitting just one step closer to the Sun, and it spins backward. Stand on Venus and the Sun would rise in the west and set in the east, the reverse of every sunrise you have ever watched. Worse, it barely turns at all. A single rotation of Venus takes about 243 Earth days, longer than the time Venus needs to circle the Sun. There, in a real sense, the day outlasts the year. Its surface creeps around so slowly that a person could nearly keep pace with the sunrise at a walking speed of about 4 miles per hour. Why does it spin this way? Two leading ideas compete, and both may hold part of the truth. The first is the brute force answer. A colossal impact early on could have smashed into Venus and reversed it, the same sort of event that shaped so many other worlds. The second is slower and stranger. Venus is wrapped in a crushingly thick atmosphere, and the Sun's pull on that heavy air raises powerful tides in the gas. Across billions of years, those atmospheric tides, working together with friction deep inside the planet, could have dragged its spin down to a standstill and then nudged it turning the other way. A world stopped and reversed not by a single blow, but by the slow, patient torque of its own sky. Then there is Uranus, which carries the strangeness to an absurd extreme. Every other planet stands more or less upright as it orbits. Uranus lies on its side, tipped a full 98 degrees, rolling along its orbit on the equator with the poles aimed outward. Think of a car flipped over while the wheels keep spinning. That's Uranus. The rings which circle the equator stand up vertically like a target you are staring at head-on. And for a quarter of its long year, one pole points almost straight at the Sun, while the other sits in decades of unbroken darkness. What tips an entire planet over like that? Once again, the prime suspect is collision, though here it may have taken more than one. One giant impact, or a string of them, struck Uranus hard enough to topple the planet and leave it rolling through its orbit for the rest of time. The blow knocked over not just Uranus, but its whole family of moons and rings, which all lie flat in the same sideways plane, the calling card of whatever struck it. Not every planet is a rebel, but even the well-behaved ones vary wildly. Jupiter, the giant, spins so fast that a day there lasts under 10 hours. Its cloud tops sweep around at roughly 28,000 miles per hour, and yet the planet sits almost perfectly upright, leaning a mere 3 degrees. Earth turns once a day at about 1,040 miles per hour at the equator. Mercury, gripped tightly by the Sun, has had its spin slowed to a strange lockstep with its orbit. The same disk produced a world that whirls around in hours, and a world that takes months. Even speed alone tells a story. Even the upright giants hide subtler marks. Saturn leans at nearly 27 degrees, and recent research suggests that tilt was sculpted slowly by a long gravitational tug-of-war with distant Neptune that the two planets fell into step with over eons. The finishing touch may have come when one of Saturn's own moons drifted too close, was torn apart, and became the rings we see today, knocking the planet free of that ancient rhythm and leaving it leaning where it stands now. The giants did not escape the story. They simply wear it more quietly than Venus and Uranus do. It would be comforting to treat all this disorder as our solar system's private history. It's not. The moment we learned to study planets around other stars, we found the same chaos written even larger. One of the strangest discoveries came from a world named WASP 17b, a giant planet circling a distant sun-like star. When astronomers measured its motion, they found it circling its star in reverse, against the way the star itself spins. It was the first planet ever caught orbiting the wrong way, and that should be impossible if the planet had simply formed quietly from its star's disk and stayed put. Something must have flung into it and reversed path, most likely a violent gravitational encounter with another planet that scattered it like a struck billiard ball. Catching a planet in the act of orbiting backward is a feat on its own. As the planet crosses the face of its star, it briefly covers the half of the star spinning toward us, then the half spinning away, and that subtle shift in the starlight reveals which way the planet moves against the star's own rotation. Read carefully enough. A faint dip in light from a star light years away can betray that an entire world is running the wrong way. And it was no fluke. The day after that find was announced, astronomers reported a second reversed world. Since then, planet after planet has turned up tilted, misaligned, or circling against the grain of its star. The neat, all-in-one-direction picture we grew up drawing turns out to be across the galaxy, often the exception rather than the rule. Wherever planets take shape, it seems collisions and close gravitational passes reshuffle them, leaving systems that spin and orbit every which way. That widens the mystery in a useful direction. The oddballs in our own backyard, Venus running in reverse and Uranus knocked flat, are not freak accidents. They are local examples of something that happens all over the universe. Building planets is a messy, brutal business, and clean, uniform spin may be the lucky result rather than the default one. Which brings the whole thing back to a simple, slightly eerie idea. The way a planet spins is one of the most honest records it keeps, almost impossible to fake or erase. The direction of the turn, the tilt of the axis, the length of the day, every piece is the end product of everything that ever happened to that world, from the disk it formed in to the last great object that slammed into the surface. Earth's gentle 23 degrees tilt is the echo of the impact that built the moon and handed us our seasons. Venus crawling backward may be the aftermath of either a long-ago collision or the slow grip of its own thick air. And Uranus, lying on its side, shows the bruise from a blow large enough to knock down a planet. Each spin is a sealed report from a time no one witnessed, and still being broadcast, if you know how to read it. So, the next time you see the planets drawn in a neat little row, all turning obediently the same way, remember that the truth is far wilder. we did not all emerge from that spinning disk identical. We came out marked, tilted, and in a couple of cases turned completely around, every world quietly carrying the scars of how it survived. The solar system is calm now. The way its planets turn is the last surviving evidence of how violent it once was. If the two strangest cases pulled you in, the backward spin of Venus and the toppled world of Uranus, we went deep on exactly those two in our video on why Venus and Uranus spin the wrong way. It's the perfect place to head next. Stay insanely curious.